Hi, our names are Katie and Katya, and we're seniors at Macalester College. Today, we will be presenting our project on creating an open-source precinct shapefile in Ohio. This past summer, we were undergraduate fellows at the Voting Rights Data Institute, a subgroup of the Metric, Geometry, and Gerrymandering group. In order to evaluate voting rights and gerrymandering, the best spatial unit to use is a precinct because it's the smallest unit at which election data are reported. In many states, there is no publicly available precinct shapefile. One of these states is Ohio.
First, we'll give a brief overview of how we collected our data and created one unified shapefile. In Ohio, as in many states, precincts are managed at the county level. Up front, about 30 of the 88 counties had shapefiles available online, and most others either had shapefiles they could send us when we called or had PDF maps as the best possible option. In the end, approximately 7 counties had no available data on precinct boundaries. We'll talk later about an algorithm we wrote to approximate that data. This is a map of a precinct in Fayette County. It's a good example of one of the over 450 maps we digitized for this project. It's also a good example of how getting the data wasn't always a straightforward process. When we called the Fayette County Board of Elections, we were redirected to Scott at Soil and Water Conservation. We thought they misheard us at first, but it turns out Scott is particularly interested in precincts, so he manages all of that data for them. He's the one who was able to send us these maps.
As we mentioned before, about 7 counties could not provide us with any data for a variety of reasons. The precincts in these places still need to be accounted for, so we wrote an algorithm that approximates precinct boundaries using voter registration data. This data includes information about a voter's address and assigned precinct. To illustrate how this algorithm works, we'll use Noble County as an example. The algorithm starts by sending requests to the Census Bureau API to get the census block GeoID for each registered voter. We then use census blocks as base units to build up to precincts. In general, precincts follow census block boundaries. For census blocks that did have registered voters, we can use their precinct designation to classify that block to a precinct. For blocks that did not have a registered voter and thus were unclassified, we could classify it based on its neighbors. This requires several iterations because not every unclassified block has classified neighbors at the start. Here's an animation to show the iterations of the algorithm in Noble County. In each map, the black blocks are unclassified, the base unit is a census block, and the colors indicate precinct assignment. We'll pause briefly so you can watch the series of maps.
In order to use these shapefile approximations, we want to have an idea of their accuracy. To do this, we use counties for which we already have an official shapefile to compare to an approximation. We'll use Clark County as an example. We use the information theoretical v-measure, which ranges in values from 0 to 1. 1 indicates a perfect match between the two categorical maps in this case. For Clark County, the global value we got was 0.96. indicating high spatial agreement between the official shapefile and the approximation. We can also get local values for spatial agreement in individual precincts. In this case, we are looking at inhomogeneity, and so we want it to be low, and 0 indicates a perfect match. We can see that the algorithm works better in large rural precincts than small urban ones. We have some more ideas about what this means and would be happy to talk about it in questions. Throughout the project, we often thought about our place and contribution to the larger civic data community. We made this project open source and reproducible so anyone could use it for their own work or verify or improve upon our results. We also experimented with crowdsourcing data collection by distributing maps to digitize to about 40 of our colleagues. We found that this helped non-GIS users better understand what we were doing. Lastly, this project helped us to be more comfortable with thinking on our feet.
Thanks for listening to our presentation. We've compiled a list of resources at the link on this slide, which also includes a link to the repository where we've collected our data. We're happy to answer any questions via comments or email.